Hi, I'm Ted Kirikiti. I spent most of my time through this app working on the Twitter API features and as well as deployment of the app and of course pair programming with the others to try to find and solve any bugs we had.
Hi, I'm Will Bridges. Some of the more tangible things I worked on for this project include implementing some of our API functionality, like patch methods to update users and their monsters. I also improved our registration process to prevent duplicate usernames from registering on the site. I secured the Twitter dev account that we needed to apply for to access the Twitter API. And early on in the brainstorming process, I pitched the idea of using web workers as a neat thing, and that turned into using asynchronous server processes, which was one of our experiments and ended up being a core component of the final website. In addition to all that, I spent a lot of time with the others in Zoom calls doing pair programming, and specifically, I helped Ted work through some of the issues he was having and solve some problems that were really important to getting the site working.
Hi, I'm Nicholas, and I came up with the idea for the app. The idea was originally an incremental idle game because I knew we didn't have a lot of time, but idle games, their appeal really comes from just the rush of numbers going up, and that was something that I felt would be easy enough to implement in the short time frame. So I came up with the idea for the app, as well as many of the features, as well as the gameplay loops of food into monsters, monsters into food, which you'll see later. I was responsible for creating most of the written parts of the assignment, such as the project plan and the written report that we had to do afterwards, as well as the very heavily minimum word counted proposal. And I also created much of the user interface for monster user creation, as well as the functions that implement that UI. Our project, Monster Browser, is an incremental game that will play itself when players are not logged in. As the previous sentence implies, players will be able to make accounts and log into their unique profile, which will be secured with encrypted passwords stored on the server. Though such security may be a bit overkill for this project, it's a requirement of the assignment, so it's gotta happen. The gameplay of the game will be similar to a monster taming game such as Tamagotchi or perhaps Kitten's game. Kittens aren't generally understood to be monsters, but some of them certainly can be. Players, like in Cookie Clicker, will be tasked with generating a food-themed resource that we're currently calling food. Food can be used to feed monsters, big surprise, powering them up, and can be used to lure new monsters into the player's inventory as well. Players are then able to send these monsters to one of two virtual locations, the farm and the wild. Monsters in the farm generate an amount of food based on their power. Monsters in the wild become more powerful. In this way, players have two feedback loops that empower the other, creating a fun and, dare we say it, eternally rewarding gameplay experience.
Hello, my name is Andrew. I'm going to be going over the features of our Monster Browser app. As you can see here, first we added user accounts and password requirements. We also implemented the Twitter API, which allows users to tweet out to their followers, and every like gives them a kind of boost to their food value. You also can see food increments constantly for all users, and even when you're away, your food is going to be incrementing. We also implemented a leaderboards shown in the second picture, so you can compare your food amounts to your friends, as well as the ability to acquire new and edit currently owned monsters. So you can see that in the first picture.
So we found that we were able to fulfill all our original design goals, and so our final Monster Browser app stayed pretty true to our original proposal. The final game loop that you can see on the website is basically the same thing as what we proposed, and our ideas for using the Twitter API and asynchronous server processes that we highlighted in our experiments also made it into the final project. However, we didn't manage to implement everything that we wanted in our stretch goals. You can see here some of the things like monster icons, combat between monsters, and then also notifications when special events happen. So these are all the instances of user interaction on the website. Upon accessing the site for the first time, users are shown this standard login screen, and if they don't have an account, they can click the users button and click add new user, then fill out this form with their name and password to register for the site. From there, they're directed to the feed, which is our homepage. The feed is where all the action happens. It shows the user their monsters and their food and power growth in real time. So the interactions you can have on the feed are feeding your monsters and also changing their location between the wild and the farm. Then you can see above that, there's the Twitter form, so they can authorize their Twitter account by clicking that button, and they're directed to the standard Twitter authorization window you can see there. And after that, they can fill in that box and click tweet, and their authenticated Twitter account will send that tweet, and then whoever likes that tweet can influence the game. So the site gives the user helpful and informative feedback for both successful and failed actions. So if you successfully send a tweet or you fail to log in because you used invalid information, then the site will display a helpful message that shows exactly what happened.
The project requirements that we meet in our application: we have proper feature separation, so we have a backend server that handles both the JSON APIs and the game logic and user sockets and channels. We have a front-end React app that connects to the JSON APIs and the channels. For deployment, we deploy to this website, monsterbrowser.tkwaffle.site. We have proper security on the user's local passwords when they register an account, with hashing and salting the password. We have authorization that we need for the API, including the developer account has some secrets that we need to store in the machine that we deployed on, and the user authentication, we need to store their OAuth tokens whenever we want to make a request using the user's account. The neat thing portion of our project is that we have a constantly running process that updates the users and the user's food and monster's power. So this doesn't require users actually connecting to the server. It's always running, and it's updating in real time to any connected channels the new values. And we obviously tested this thoroughly with all 4 of us on deployment, and we're all trying to get to the top of the leaderboard. For the challenges of the project, kind of the main challenges were between the Twitter API and auto-incrementing food and power through a broadcast. So for the Twitter API, we had a lot of trouble figuring out all the specific settings we needed to match between the Twitter account and the developer account and the application, and also making sure we had the right authorization at all the right times. So when a user authorizes, we need to grab their authorization and store it, and when we want to make an action on their behalf, we need to make sure we're setting the config for their user account, and then also making sure any other requests after that aren't using their account when we're not meant to. So that took a lot of debugging to figure out. We needed to make sure we found out how to set the configs properly, and we took a long time with in production. We realized we had the wrong redirect URL back from Twitter, which was not giving us any logging when it errored out. We also had in the socket connection for broadcasting, we had some trouble when we were trying to pass the user object directly through the socket. We had to actually convert it into a simpler map object with all the values, and also some trouble with the socket, particularly switching over to production or deployment. We had to have the right URL for the socket and make sure that it was set up in the Nginx config.
The neat feature of this game is It's the fact that it is, in fact, an incremental idle game. Um, I've used that term several times before, but in case it hasn't yet been defined, the core conceit of an idle game is that the game state updates and develops itself even when no user is currently logged in. Of course, having a persistent server state was a requirement of this assignment, but it's also just generally a requirement of an idle game because even as a player isn't actively involved in the process of the game, their state is still developing. So a lot of the gameplay actually involves optimizing your off time, essentially making the game as efficient as possible when you're not playing it, so that it develops itself to its maximum potential even without your direct oversight. Because of this, every time a user logs in, really, no matter how much attention they've paid to the game recently, they'll be in a better position than they were before, which is evidently a very, very popular schema in the field of games nowadays, given how many of them there are. Arguably too many, but we made another.
All right, so I'm going to be demoing our app. First, we have a nice login page. We have some tabs at the top, but first I'm going to log in to my user account. All right, so you hit login, and then your feed is going to now update to list all the monsters that you have. So each monster has a nickname, and you can change the nickname. So I'll name this one Powerful Monster. You can see that updates in the list. It also has a species, a power level, and a location. If you want to increase the power level of your monster, you can either feed it, which spends food. As you can see, it increased in power level. You can also switch it into the wild from the farm. So if I switch this location, now this monster, it's going to increment in its power level, but it's no longer going to contribute to my max food per second unless I switch it back. So now you can also buy new monsters. Click that, you can see I've just purchased a new monster. It starts at power level 1 and it's randomly generated name and species. I can feed this monster, make it more powerful. As you can see now it's super powerful. If you want to compare your progress to your friends, you can go into the users tab and you can see a running leaderboard. So as you can see, I'm right below Will and right above Olivia. If you log out, and your feed is just going to be this default homepage. And those are the main features of our app. You can also make a new user. We've done this many times before. So I'll just name this one Test 2012. Okay. And password, we have certain requirements. So I'm going to name this password 123. Password 123. Save that. And so now I should see an update in the user list and I can log in. So test12, password 123, log in from here. And now you can see my feed is going to start with no monsters. The first monster always costs 0. So I'm just going to buy a new monster. Every monster after the first one increments in how expensive it is. So soon I'll be able to buy a second one. And then now you can see it goes from 0 to 10. Now it's 100. The next one's going to be 1,000. So there's constantly a way to progress, but your progression gets slower and slower as you go. So those are the main features. I'll show you the authorized Twitter in the next slide. All right, so for the Twitter API, you can click this authorized Twitter button, and this will bring you to this page. If you click authorize, now you get a successful message. You can now tweet from this tweet bar. So I'm just going to type a quick message here, hit tweet, you'll get a little notification. Then if you go to your Twitter and refresh the page, you have a tweet. So another aspect of this is that anyone who likes these tweets will give a boost to the food that your monster has. So it's very useful. It gives some social aspect to the game, and yeah.